In this video, we'll be covering lesson 13.3. You will need your book for this assignment when it comes to finding some of the answers. And what I mean by your book is to be able to follow along in your examples for this lesson, but also be able to use Appendix D, which is in the back of the book. So we're going to jump right into example 1 here. What we're doing is we're looking to find time and rate. So some of the pieces that we've already been provided in the past, now we need to look at how to locate them. So in example 1, we have a principal of $29,000 and a maturity value of $45,000. What we're looking to find is our time. So the way we're going to do this is we're going to go equals, divide principal, divided by time, or divided by maturity value. I apologize, it's going to be the other way around. It's going to be maturity value divided by principal, and we're going to get a 1.55172438 number. Now, what we're going to do for this is we're going to go to the back of the book where it says Appendix D, and then we are going to locate what would be the time that we'd be needing for this. So if you look at the example on page 502, you will see in example 1, we have 45,000, 29,000, and then it says 10% compounded annually. So now let's go to the back of the book, and you're going to find in Appendix D, we are looking to find the 10%. So if you go to page 846, you will find in the top left-hand corner 10%. Now what we're looking to find is located in column A. If you see column A, it says compound interest. We are looking to find the 1.55, what number in column A, compound interest, is closest to our 1.55. And if you look down at that, you will see that it's 1.61051000. Since that's the closest, then we could look over to the left and say, okay, 5 is the time that we would need for this. So the question was asking again, finding time. And we were able to find the rate that is closest to it by going and dividing the maturity value divided by principal, and then looking at the 10%, we were able to go down until we found the number that was closest to that number. And so your answer would be 5 for this one. Now, for example 2, there is no formula or anything that we're using for this. We are looking to find how long will $1 double to $2. And all we're doing for this one is they also provide us the 4%. So let's look at the 4%, which is located on page 836. And from there, you are going to find what number in column A, compound interest, is closest to the number 2. So if we look down on page 836, we would find that 18 is the amount of periods or the amount of years that would be needed to double from $1 to $2 for it to completely double. So from 1 to 2, it would take 18 years at a 4% rate. All right, so we have used Appendix D for example 1 and example 2. Now we're going to go on to example 3. In example 3, we have a principal of 8,000. We have maturity value of 8,493. The time they give us is going to be 1, and the compound periods is quarterly, so that is going to be 4. I'm sorry, it is compounded monthly, so it's going to be 12. Now, what we're looking to find for this one is our rates. Now, this one's a little more difficult to find for the Appendix D. So we're going to go equals maturity value divided by principal to find our number that's going to help us locate our rate for 12 periods. So now we're going to the back of the book, and we are going to have to flip through the different pages of where we see the number 12. So if we started looking at the number 12, if we started at a third percent for number 12, and if we looked at 5 over 12 for the 12 period, and then if we looked at page 824, number 12, we'd find that 1.06167781 is going to be the closest that we'd be able to find for this rate. I know that's not the best method, but that's the method they share in the book, to be able to flip the different appendix, to be able to locate these different rates. So the rate that we would have would be 0.5. Now, what we're going to do with this is we're going to take our 12 periods times our rate, so 12 times 5, and so our answer is actually going to be 6%. And that is because that is the original rate before it is divided down by the amount of periods, which is 12. All right, last problem, example 4. In example 4, we are taking, if you look at the example here, we start with 2,500, we start with 6% compounded quarterly, so 1.5, and then we have years of 4 years, so 16. And then it goes on to say, after 4 years, the rate dropped to 5%, and then it's compounded semi-annually. Find the amount in her account at the end of 7 years. So this first number will give us the principal that we need for the second part of the problem. So we're going to go principal times, parentheses, 1 plus I, parentheses, exponent, n, or time. So at the end of 4 years at that percent compounding that much, we'd find 3,172.46. Now we need to find the rate for the remainder of the 3 years. So if we look at that, it's now 5% compounded semi-annually, so we divide the rate, the rate for this, and then we multiply the time. So for that one, we're going to go 3 years times 2, because it's semi, and 6. And then we can go equals, we go principal times parentheses 1 plus I parentheses exponent n, or time, and so 3,679.08. So this is lesson 13.3. Again, you'll be using the appendix in the back to locate these different times and to locate the different rates. Again, for this one, for the times, you're looking to find, after you locate the interest rate, you'll be using that first column A to locate what number is closest to it. And then for example 3, finding rates, you know the amount of periods, so you're going to flip through the different rates in the back. And then example 4, you will not have to use the appendix D at all, since we have everything provided for us. So this is lesson 13.3.